der Automation Podcast. Herzlich willkommen zu einer neuen Folge über Technologien, Trends und Nutzen von Automation.
Wir, das sind Kurt Bettenhausen und ich, Thomas Tauchnitz. Wir freuen uns darüber, dass ihr in dieser Folge dabei seid. Bei uns hört ihr interessante Gäste zu spannenden und aktuellen Themen der Automation.
A very warm welcome to Peter Weckesser, Chief Digital Officer at Schneider Electric. Peter, please introduce yourself to our audience.
Yeah, first of all, good morning. Thanks for having me today. My name is Peter Weckesser. I'm the Chief Digital Officer at Schneider Electric, and we will certainly talk a little bit more about what I do in my role as a Chief Digital Officer today.
Yeah, thank you. Our title states AI needs energy and energy needs AI. That's a fascinating combination. What does that phrase actually mean in practical terms for business and society over the next decade?
Yeah, let me maybe start with the first part of that statement. AI needs energy, which is the more obvious part, and it's very much in the public debate. The build out of our AI infrastructure, the build out of data centers, the build out of AI factory is actually constrained not so much by the number of GPUs available, but it's very much constrained by the access to energy. Energy and access to energy became the single biggest challenge in the build out of this technology that will influence most likely every industry and every company pretty significantly. So it's a well-known fact that AI is energy hungry. AI needs a lot of compute, and we will certainly go into how efficiencies are being achieved. But it's simply a fact, it needs a lot of energy, and this energy needs to be provisioned. Now, what does it take to provision that amount of energy? First of all, this energy needs to be generated. And there's, of course, all forms of energy being used today. Fossil energy generation, renewables, nuclear, everything is in the mix. And it's very clear that there's a requirement from the AI side that more energy and of course the best energy is sustainable energy from renewable, that this gets created at scale. Second, that energy needs to be distributed, and also there are very significant new requirements towards the distribution grid, and this is very much connected also to the build out of renewable energy resources, which are mainly wind and solar. Wind and solar are highly distributed, and they come with pretty significant new requirements to the grid, which becomes in the future way more complex, and it has to become intelligent, this grid. Now, this takes me a little bit to the other side of that statement that energy needs AI. If we think about the grid of the future and the grid, and maybe I describe the old grid and the new grid on a super high level. In the past, and this is still the case to a high degree today, we have a relatively small number of very large power plants. The electrical energy that's being generated first gets transmitted, and then it goes into the distribution grid, medium voltage, low voltage distribution grid, to be made available to all the consumers. So this is basically a one-directional energy flow from the energy generation to the energy consumption. Now the new grid becomes way more complex, and we all know that solar on rooftops, large solar farms are being built out at a significant scale. Also, wind is being built out, and these are highly distributed, much smaller amounts of power generation, but highly distributed in aggregate. In most geographies in the world, renewables represent by far the most significant addition to our electrical energy generation. Now, the nature of these renewables is that they will have a significant demand to the build out of the grid as well. So because they become part of the distribution grid immediately, and that means the distribution grid we need to make significant investments into our distribution grid. Now the distribution grid, as it was built many years ago, was built for maximum capacity. Now, as we put more load on the distribution grid, we have two options, or the combination of two options. We can build out this distribution grid and basically put more copper into the ground. This would be the most expensive way, because we would have to design that distribution grid for its maximum capacity and it's designing it for peak. Now what we really need to do is make this distribution grid intelligent, because now you have energy flows between all these producers of energies, wind turbines, solar panels, and these might be large solar parks, or it might be a solar installation on a home. And that means these energy flows need to be controlled. Let me bring one more aspect into this. Renewables by nature do not provide energy at any given time of the day. Of course, you need sunshine, you need wind for renewables. So you have the need to store energy as well. So you need to also build storage capacities. This is battery parks or the electric fleet, the automotive fleet that is growing and growing to store that energy. And from this description, you can already see that actually every home in the future becomes what we call a prosumer. A prosumer is an artificial word of a consumer and a producer. That means every home, every industrial site, every building will be generating energy, but it will also be consuming energy. So at certain times, this asset, the home, the building, the industrial site, will provide energy to the grid, or it will consume energy from the grid. Robbie, I take a quick pause here for you to give me your next question.
Peter, thank you very much for the holistic introduction and the big picture. When we tried to assess this a little bit, what do you believe are the biggest energy and infrastructure bottlenecks you see emerging? And furthermore, how can industry address them properly?
Yeah. So very good segue probably in the next part, but I want to go into a little deeper. So the public debate is very much about sustainable power generation, about renewables. So the public debate is less about demand side management, and this is where the second part of the introductory statement, energy needs AI, comes into play. If you think about the evolution of the distribution grid that I have been describing, then it's very obvious that all of a sudden we have to deal with the complexity of the grid, which has millions of participants, millions of these prosumers being part of that new grid infrastructure. And that's not something for the future, but it's already happening today. Now, in order to stabilize the grid, the utilities will have the challenge that they will have to know from each participant in this distribution grid how much energy do they need in the future. That means in the next 15 minutes, in the next hour, in the next 24 hours, or how much energy will they be able to contribute to the grid. Now, you can imagine this is a non-deterministic problem where you have millions of participants, and this way AI will be playing a major role, because there is not a deterministic control algorithm that can deal with this kind of complexity. By the way, the grid structure will change on a daily basis, new participants being added to the grid, some participants potentially being removed from the grid. So in this new world, basically every participant that is your home, but it's also an industrial site, will be asked by the utility, by the grid operator, to provide not only current consumption or current production of energy, but also providing forecasts for future consumption and production. And this leads us into the demand side management, and also into the management on when do we need to store energy in the battery capacity that we have available. And as you can imagine, AI is starting to play a major role here. Millions of data points, that provide current consumption and production, millions of data points that provide future production and consumption. And from that, the AI will be deriving the right decision making, which is, should we charge the battery capacity? Should we drain the battery capacity because there's so much energy need right now and not enough wind and sunshine? Or should we also manage the demand side of large consumers of energy, very large industrial sites that have some flexibility when they can consume their energy? AI will be playing a major role in this. And I'll give you an easy example that as a consumer, probably most people today or in the future will be able to relate to. If you think of your home, and if you have a home where you have maybe a solar panel on your rooftop, of course you have a grid connection, and you might have an electric vehicle in your garage. So if you think about your own energy consumption, of course, it's ideal that you consume all the energy that is generated by your solar panels directly in your home. And there are a couple of scenarios that could happen. Sometimes you don't produce enough energy, so you need additional energy from the grid. Sometimes you produce more than you need. You have then probably two options, maybe three options. You could start certain workloads that consume energy in the home. That's maybe not totally realistic to do that, but you could start your washing machine and other appliances to consume more energy. If you have excess of energy, you could charge your car, which would be probably the smartest way to store that energy, because if you put it into the battery of your car, you can either use that energy for driving your car, or you could discharge your car at times when there is a lack of energy. And the last option is to feed the energy back into the grid. Now, this seems to be like a pretty complex scenario, right? Who makes this decision? You don't want to have an app on your phone where you basically make these decisions online in real time. But you want to have a very smart algorithm in the background that makes these decisions for you. And of course, this very smart algorithm does not only need to know about energy production and consumptions and future forecasts, but it also needs to know about what is your personal behavior, right? When do you want to use your car? Of course, when you want to use your car, you'd prefer to have it charged so that you can go where you want. And so bringing this all together will be based very much on AI algorithms to manage the microgrid in your home. But then AI will also play a major role in the interaction of millions of microgrid within the distribution grid.
Yeah, thanks for this explanation, Peter. It shows really the necessity for AI, because I think nobody will like to manage that manually. That leads to the question.
I would even say it's impossible to manage it manually, right? So the manual overrides, I think a manual override will be possible, but I think it will be only used in exception cases.
Peter, historically, technology becomes more efficient by time, but overall usage increases. So do you expect AI to reduce energy consumption overall, or will the efficiency gains be outweighed by the explosive demand of computing, what seems to be the fact today?
So this is a very interesting question, which is, of course, widely debated. So all the forecasts that I'm aware of, and also our own forecasts at Schneider, show that the demand for AI factories or data centers in terms of energy will be significantly growing. It's actually the fastest growing industry in terms of energy demand. So that energy demand is predicted to double within the next couple of years. Still today, the total consumption of energy out of the global consumption for data centers is only at 4%, but it's growing rapidly. Now, of course, this is all of our demand for AI. So everything that we do with AI, it's all the AI that we use for software engineering or for all the cool large language model tools that we all use on a daily basis. You have perceived that internet search is becoming very much AI based and AI supported. So this consumption, this of AI drives a higher energy demand for AI. So this goes without saying, but it's really across everything that we all do and across everything that we all use AI for. Now, at the same time, technology is, of course, improving. So you could look at a GPU as an energy to token converter, right? So that's a very simplistic model how to look at a GPU. And of course, this gets better over time. So GPUs become more efficient, so they create more tokens per unit of energy that they consume. So, and every generation will become better. And by the way, it's not only the GPUs, it's the whole data center that gets better in its energy supply infrastructure, in its cooling infrastructure. Next generations of data centers will fully go to liquid-based cooling, which will drive a higher level of efficiency. So it's totally clear the technology will get better over time. So, but it's not only the hardware technology, so it's not only the energy supply and cooling and the GPUs itself, it's also the software algorithms, right? So all the software companies that are part of that AI stack, and that certainly starts with the large language models, but then also algorithms on top, become better in terms of how many tokens they need to consume. So I see that the industry is driving significant energies, and that ratio of token per watt will get better in the future. But it's also very clear the amount of tokens that we all consume for all AI-based application continues to grow pretty significantly. And then there's what we talked earlier about, that we also will be using AI for the optimization of our overall energy infrastructure, of our overall grid. This is very clearly a very positive equation. The amount of energy that it takes to generate the tokens to optimize the grid is a very positive investment into sustainability.
Thank you, Peter. I believe all of your answers already provided a solid foundation for our audience. But let's try to make this a little bit more tangible as well. So where is AI already creating measurable value in energy systems today? Can you share a few examples, not in pilot projects, but in real-world operations?
Yeah, we have a good number of real-world operations where we use AI to manage microgrids. There's an example of a very large shopping center, a mall in Finland that has deployed a full microgrid installation with on-site power generation, with battery capacities, with demand-side management, and also in this shopping mall. It was decided to use AI-based algorithms from the very beginning to drive optimization of the whole installation. So that's tangible value. Then you can see, and I want to give you two more examples. Then you can see that this is coming more and more in the home space. And in the home space, we talk about the home energy management systems, or the HEMS controller, which we will all see in our homes in the future. This is an intelligent device that will go into your electrical cabinet in the home. And this is not totally, it's evolving, right? But the technology is available. You can buy this from us and others. And basically this becomes the brain of your home when it comes to the consumption and distribution of energy. This HEMS controller does exactly what I was explaining earlier, that it controls the energy flows between your solar installation, the grid, the battery, your electric car, and optimizes the energy consumption for your home, which results into real savings. And when I say this is available for homes, this is of course available for buildings, commercial buildings, and office buildings, and also multi-apartment buildings. This is available already today as well. Last example is actually data centers. Data centers is super interesting, right? Data centers are a very active participant to the electric distribution grid. They are power hungry. They have very large consumption of power. And we are one of the leading providers to electrical and distribution and cooling infrastructure into these data centers. And we are working with all of our customers to optimize this energy consumption in the data center. And by the way, this is actually the same technology that we also use for predictive maintenance of all the assets that are in the data centers. This is our equipment that we sell to the data center operators, serving two purposes: really optimizing the energy flows in the data center depending on the load that's on the data center, and also providing predictive maintenance information on which asset needs maintenance at what time, because data center operators certainly have this requirement of 100% availability of their asset.
Peter, you spoke about homes, data centers, office buildings. How about industrial companies who are producing? Where is the biggest untapped opportunity at the intersection of AI and energy management for these industries?
So, look, industrial companies are a bit similar to data centers. The data centers are now called AI factories, right? So it's a factory that produces tokens. And if you look at other factories, no matter if this is automotive or chemical, they all need energy, and they produce a wide scale of very, very different products. Now, all of our customers, also on the industrial side, have that challenge to optimize their energy consumption, which is, of course, using the right energy mix, and that's a mix between on-site generation, that might be with combined cycle plants, that might be with solar or even wind, but all of our industrial customers also still have a grid connection today. So also an industrial site is a microgrid that needs to be very actively managed, and all the principles that we debated for homes and data centers before apply exactly the same way for industrial production sites. And industrial sites certainly, depending on the nature of your processes, have the capability of a demand side management, right? So certain industrial processes, that particularly the ones that consume very high amounts of energy, if the customer you can start these processes at time where there is an excess of energy available in the grid, because this energy becomes much cheaper. So if you have a windy day with sunshine, that's the ideal scenario to start high energy intensive processes, like take an aluminium smelter, for example, which you can operate, of course, only with large amounts of energy. And this energy, you want this energy to be as cheap as possible. And this is, of course, happening at times where there's an excess of energy. So for many of our industrial customers, this part of the demand side management, that you start your energy intensive processes at the right time, becomes a key topic. And let me just make one add-on to this. Actually, some of the energy intensive but very slow processes fall into that category as well. This is particularly heating and cooling processes. Heating and cooling processes for buildings, right? So a heating process is usually a very small process. You can start that an hour earlier or an hour later. The building itself will preserve that energy at least for a certain amount of time. And using this for the very slow processes, that you start them and stop them at the right time, is a very important part of the demand side management. And also, again, this will be very much controlled by AI, because you do not only need your production schedules, but you also need to have the forecast on when are the energy prices being lower, to calculate really the optimum time to start your business processes.
Peter, let's try to connect a few more dots. Before AI became such an important topic, we talked very much about digital twins and simulation models over the last decade, or even for a longer period of time. You mentioned predictive maintenance and the similarity of the tools already. Schneider Electric has invested heavily in digital twins and industrial software over the past decade. And how does generative AI support the role of digital twins in managing and predicting energy-intensive operations?
Very good topic. Let me go into this a little bit. So far, we have mostly talked about the operations phase. Now, if you think of digital twin, we are starting to talk about the engineering phase. So, and at Schneider, we have our own capabilities for the design of the electrical system, design of the electrical grid, and also very, very strong simulation capabilities. We have the same with our software company Aviva that has strong capabilities on the process engineering side. So if we think of this, AI is starting to play a major role in the engineering process. So while in the past, the designers, let's say the designers of an electrical system started to design with graphical desktop tools, it's called single line diagrams, which basically is the representation of a digital twin of an electrical system. Now we see more and more that AI tools become a very, very relevant part of that engineering process to really have a much faster time from idea to fully built and fully simulated digital twin. And let me go into this simulation part because that's key, and that's already something that we are offering to many customers today. While the engineering process is usually concluded by validation and simulation that tells you, hey, yes, my digital twin does exactly what's intended to do, and once that's validated, you can start in building the real asset. And let's say that asset is the full electrical distribution system of a data center. Now, as we then also do not only provide the electrical design for the data center, but we provide a lot of equipment, that's the low voltage distribution assets, the cooling assets. This is all part of the initial digital twin, and then we help our customers to build the real asset. That, of course, puts us and our customers into that position that we can all of a sudden not only take the real data from the real assets and try to build again physical models, but we can use the simulations that we have used to simulate the digital twin also for the real asset. So this puts us into the position that we can really bring together the digital twin and the real twin and compare the simulation results of the digital twin with the real life result of the real asset. It also puts us into a capability, and we call that energy intelligence, to interact with a real digital twin in a very different way. And under this, and I want to give you maybe one or two examples on what we mean by energy intelligence. We can now ask natural language questions to the real asset, asking, when is the next maintenance required? And what is the best timing for that next maintenance? And give me all the assets that need maintenance in the next 10 days, right? This was not possible in the past. Now we can ask these kinds of, with the help of AI, based on top of our operations platforms, we can ask these natural language questions to get a full list. Hey, these are the 15 assets that need maintenance in the next 15 days. But we can also ask very, very, very different questions. Is what if we have a failure in one subsystem of the electrical distribution? And by the way, electrical distribution within data centers is always redundant. But now you can go through scenarios where you say, what if we had a failure in this medium voltage subsystem? Can we still sustain the operations of the data center, or do we need to have emergency power supplies to kick in? So we can go through all these kinds of simulation while the data center is running. And of course, the AI is now capable in case if you have really an issue that a subsystem has a problem, that within fractions of seconds you can compute the scenarios in a what-if model and then take the most appropriate counteractions. So AI plays a major role in the engineering process, building that digital twin, but then connecting the digital twin to the real twin, and using the data, the design data, together with the operations data for AI.
Okay. So, Peter, now that we have built the solid foundation, we talked about pilot projects and real-world operations on top of them, in the industrial space, in also the domestic buildings that we see in our neighborhoods. How close are we to a future where buildings, factories, and microgrids autonomously optimize their own energy consumption using AI? And by how close, I mean more than 80% are using it seamlessly.
So, very good question and not easy to predict, right? So let me give you the answer in 2 dimensions. The technology is moving at rapid speed, and many of these asks are actually doable with today's technology already, right? So if you use the latest technology that's at our hands already today, we can build autonomous microgrids that self-optimize the energy consumption of a defined asset. Now, adoption is probably the bigger challenge because this requires investments, this requires clear return of investment calculations as well. And some of these industries are moving relatively slow. And if we look at this from a global perspective, we can see that China is moving faster than anybody else into this direction, and other geographies are much slower than China, for example. In Europe, we are also slow, much slower than China, and I think we need to push on the adoption of these technologies because there are clear and tangible benefits already available today. Yes, there's of course some investment required, and just to give you one number, we are talking big numbers. If you think about the build out of the distribution grid in Europe, and that's only EU Europe, then the forecasted number is that the investment required will be 70 billion per year over the foreseeable future. So pretty significant investments, but it's an investment where Europe cannot stop or even wait, because out of all geographies, Europe is probably the one that's most dependent on energy, and we need to drive the energy transformation more quickly than other geographies that are less dependent on external supply of energy. And when I say energy, I of course always mean at the end we are generating electrical energy from whatever the original energy source is.
Thank you, Peter. Let's change to the human side, the workforce. As AI becomes embedded in energy systems and industrial operations, as you described it, what skills will the automation engineers and energy professionals need so that they can use it, and which skills which they don't have today typically?
So let me first answer this question on a bit of a higher level before I go into the specific requirements of energy and automation engineers. What we are seeing happening is the most rapid evolution of technology that I've seen in my career, and this is something that excites me. I think it's the most interesting phase of my professional career so far, because technology is moving so fast. Sometimes I also get a little bit worried, and if you only look at the last 6 months, you can see an evolution in AI technology which becomes extremely transformative. And probably the most visible area is software engineering today. While software engineering was probably, or a software engineer was a skill that was kind of challenging to find the best people in the market. This is totally changing now, that software engineering business processes will change dramatically. So most of the coding, most of the generation of test cases, most of the testing will be done by AI. Humans have more the role of oversight and creating the right architecture. Now, this will change an ecosystem of software engineering pretty significantly. Now, I came to the conclusion, I believe that this is not only happening in software engineering, but it's happening for all of knowledge work. And knowledge work is in finance, in sales, in marketing, in HR. So I expect a transformation which is bigger than the internet transformation 30 years ago, and it's moving at a faster pace. Now, what does that mean for our workforce, and what does that mean for skills? Certainly, it's fair to say that not total jobs, but tasks of jobs will be replaced by AI. And companies probably better start getting their arms around that to understand which of my jobs, which of my functions will be impacted by AI and how much. And what does that mean for our workforce? And there might be different conclusions, but I'm pretty sure that everybody's role will change. There will be certain tasks in my role that will be done by AI tomorrow. There are other tasks that only emerge through AI, right? So I'll be dealing with other things that AI can't do yet, or AI will create some other challenges that need to be dealt with. But I think every company has the responsibility to look into this and to understand what is the impact of AI on the workforce. We are doing this very actively at Schneider. And going now a bit more specific into your questions, while I'll believe the role of any knowledge worker will change through the impact of AI over time, and in some areas pretty quickly. I'm deeply convinced that for our automation and energy engineers, their role will change. By the way, not everybody has to become a developer of AI products and algorithms or LLMs, but everybody will be using these, right? So everybody needs to think about, and companies need to think about, how do we have to upskill our workforce that they can use all these AI capabilities in the best possible way? And I don't think there is any way around upskilling and continuous learning on this. And I think we need to embrace this transformation very quickly because it's moving at rapid speed. We need to go into a more strategic workforce planning. We need to go into a clear upskilling, learning and training capability. And everybody, and I really mean everybody, will need to learn how to use the AI capabilities in the best possible way.
So Peter, if we take a closer look into our calendars, schedule a follow-up in 2035 and polish our crystal ball a little bit, what development at the intersection of AI and energy would probably surprise people the most?
Look, I think in 35, which is roughly 10 years from now, I think what we have been speaking about, how we make the grid more intelligent, how we provide more renewable energy, more sustainability in the management of this. I would hope that this all happens in the background, right? So that we have built out our fleet of renewable energy generation, that we have built out our battery capacities, and that we have built out our grid, and that we have made our grid fully intelligent and autonomous, so that this all happens in the background without much human intervention.
And let's get to a bit more personal question. What motivates you, Peter? Getting up every morning, driving change at the intersection of the old technology, energy transmission and distribution on the one hand side, and the new technology, AI. What is it?
Look, I find it, I said it a few minutes before, the most exciting phase of my personal and professional career, right? I had the opportunity to live through the internet transformation. I still remember my first email, my first website that I went to, right? So I'm in this group that grew up before the internet. If we go 30 years back, right? and compare this to today, we couldn't do anything without the internet anymore, right? We couldn't record this podcast. We couldn't watch the movie from last night. We couldn't shop what we were shopping over the weekend. We couldn't find the way to the next place where we want to go. So the internet is everywhere and has influenced all of our personal lives and all of our professional lives as well. Now, and I think AI will be exactly the same. But probably moving at an even faster speed. And I'll let you judge if this is good or a bad thing, right? I find it definitely exciting that a technology is gonna transform our private and also professional lives. Now, why do I find that particularly fascinating in the role that I am in? Is, of course, AI is the foundational technology that's driving that change. But I hope it became clear from our discussion that AI and energy are really connected by the hip. There is no AI without reliable and sufficient and sustainable energy supply. And on the other side, there will not be energy without significant support of AI of controlling the energy flows. So two technologies connected by the hip, and I find it totally exciting to be part of that ecosystem where energy companies and AI companies work hand in hand to deliver the next foundational technologies.
Okay, I feel your enthusiasm, which is a good feeling. Peter, are there any topics we have not discussed yet which matter for you and might matter for the audience?
Look, I think we covered a lot of ground over the last 40 minutes. And if I have only two messages for nothing new that we haven't covered, then it's probably two main messages that I want to underline. Message number one is, AI is a transformational technology that will impact all of us. Every industry, every company, every person will impact our private lives. And it's very much coupled with the energy transformation, right? So these two things go hand in hand. That's probably message number one. Message number two is, this is a real transformation. This is a transformation that will have an impact on our jobs, on our tasks. It will have an impact on our private lives, right? So, and there will be two options. You can fight that transformation and most likely will not win, or you better embrace it, right? And adopt, apply, and transform wherever that makes business sense.
Peter, with this, we have reached the end of this episode. Typically, we ask our guests for 3 key messages. You addressed it all in a very fine way. If there's nothing more to add, I would like to thank you very much. It was a great pleasure for us having you as an international guest in our podcast.
Thank you so much. It was a pleasure for me. Thanks for having me. Thanks, Kurt. Thanks, Thomas. Really enjoyed the conversation today.
Thank you. Schön, dass euch diese Folge bis zum Schluss fasziniert hat. Uns hat es Spaß gemacht. Euch hoffentlich auch.
Wir freuen uns, wenn ihr auch bei der nächsten Folge wieder mit dabei seid. Bis zum nächsten Mal beim Automation Podcast.